viewers, welcome to IDC Learning Center. This is Jeff Peter. Today we are going to be solving questions on physics Jamb. Alright, most of the questions I'm going to be solving, they are repeated questions in Jamb examination. For those preparing to write their Jamb next year, you're going to gain a lot from here. Join me in class.
So we start with the first question here. Question 1 says, a man walks 1 kilometer, due is and then due not. His displacement is dash. Man walks 1 kilometer, due is and then due not. His displacement is dash. So for us to answer this question, we'll use our 4 cardinal points, right? Here is your east, here is your north, here is your south, and then here is your west. So the man walks 1 kilometer due east. Here is our due east. We have 1 kilometer here. Then he also walks due north, same kilometer. So due north 2 is 1 kilometer. Then what is his displacement? The distance between our north and east here, right? So let's draw a line connecting north and east here. So we are asked to find the displacement of the man. Alright, so from what we have here it forms right angle triangle here. So for us to find the long side, which is said to be the hypotenuse, we're going to make use of our Pythagoras theorem. Okay, so the square of the hypotenuse is going to be the sum of the square of the two other sides. So let's represent our hypotenuse with r. It's going to be equals to the root of 1 square plus 1 square, right? So our r is going to be 1 square is 1 plus another 1 square is also 1. Or r is going to be the root of 2, the square root of 2. So that's the value for the r. So we're going to find the angle now, the angle of inclination of the north and then the east here. So we have opposite given and then adjacent given, so we are going to make use of tan. Alright, so let's represent the angle with theta. We are going to be having tan theta equals to the opposite all over the adjacent, 1 all over 1, right? So our tan theta is going to be equals to 1. So to find our theta, we're going to find the tan inverse of 1. When you do this, you're going to have your answer as 45 degrees. Alright, so combining the resultant and then the angle now, we're going to be having what? Our resultant is 2 kilometer. That's the square root of 2 kilometer, right? Then the angle north of 45 degrees is. So this is going to be our displacement. Therefore, our answer for this question is going to be A. Right, so that's for question 1. Then let's go to question 2. Question 2 says, the density of the oil was 0.9 grams per cm cube before frying. If the density was 0.6 gram per cm cube after frying, assuming no loss of oil due to spilling, its new volume was. Okay, so we're asked to find the new volume of the oil now. Alright, so let's get our data. We're given the first density, let's call it initial density, D1, at 0.9 grams per cm cube. Alright, then the final density, let's call it D2, is given as 0.6 grams per cm cube. Alright, assuming there's no loss of oil due to spillage. So if there's no loss of oil due to spillage, then we are going to maintain the same volume. Alright, so our V1 is constant, 400 cm cube. There's no change. Alright, so to find the final volume now, V2, that's what we are looking for now. Okay, so we're going to be using the formula D1 V1 equals to D2 V2, right, for us to solve this very question here. Okay, so we are looking for V2, that's the new volume. Making V2 the subject formula in this equation, we are going to be having, we're going to be having our V2 is going to be equal to D1 V1 all over our D2. Right, so substituting the values, our D1 is giving us what? 0.9 grams per cm cube. Our V1 is giving us 400, that's constant, all over the D2, which is 0.6. Okay, so when you multiply and then divide this, you're going to have your V2 as, multiplying and dividing, we are going to have 600. So our V2 now is going to be equals to 600. Volume is measured in cm cube. So therefore our answer for this question 2 is B, 600 cm cube. 600 cm cube. Alright, so the next question, question 3. Which of the following is true of an electrical charge? Which of the following is true of an electrical charge? A. Positive charge means deficit electrons. B. Negative charge means excess of electrons. C. Electric current means movement of electrons. D. All of the above. Okay, so when we talk about electric charge, generally the three options we have here, they are all right concerning electric charge. Positive charge is talking about the insufficiency, or let's use the word deficit electrons. So when there are no deficit electrons, then it's said to be positive charge. Positive charge contains only protons. Negative charge contains only electrons. Alright, then the electric current now, it's simply talking about the flow of the electrons, the movement of the electrons. So all of the above is correct concerning electric charge. Therefore, the right answer for this question is option D. So let's go to the next question. Question 4. Natural radioactivity consists of the following. Or natural radioactivity consists of the emission of, emission of A. Alpha particles and beta rays, B. Alpha particles and X rays, C. Alpha, beta rays and gamma rays, D. Gamma rays and X rays. The correct answer for this question is C. Natural radioactivity consists of the emission of alpha, beta rays and then gamma rays. Right, so all of them are natural radioactivity. Okay, so the next question here is question 5. Question 5. Which of the following does not describe the image formed by a plane mirror? Which of the following does not describe the image formed by a plane mirror? A. Erect. B. Laterally inverted. C. Same distance as the one from the mirror. Okay, same distance from mirror as objects. D. Magnified. The correct answer for this question is option D. Option D is the correct answer for this question. For a plane mirror, you see the image is erect. Erect means it's upright. Then B, plane mirror, the image is laterally inverted, which means it is the opposite, or let me say it's upside down of the object. Then the distance too, the same distance of the object from the mirror is the same distance of the image from the mirror. So option D is the correct answer. Images formed on plane mirror are not magnified, they are diminished instead. Next question is question 6. What is the resultant resistance of the circuit with two resistors, 2 ohms each, arranged in parallel with 3 ohms and 4 ohms arranged in series respectively? Okay, so this question is having two arrangement of resistors. We have the ones in parallel and then we have the one in series. So usually the best way to get this done is you start resolving the resistors in parallel so that you can add them to resolve in series. So we start with the one in parallel. Okay, for finding the resultant of the resistors in parallel, we use our formula 1 all over R equals to 1 all over R1 plus 1 all over R2. Okay, so 1 all over r is going to be equals to our r1 now is 2, so that means 1 all over 2 plus 1 all over r2 is giving us 2. Right, so to get this done we can use LCM or we can do it direct. Let's use LCM. LCM of 2 and 2, let's use 4. Right, this is still 1 all over r. Okay, so 4 by 2 is 2, 2 times 2 is 2, plus 4 by 2 is 2, 2 times 1 is 2, right, which is going to be equals to 4 all over 4. So we are looking for r, not 1 all over r. So to find r now, we have to take the inverse of this fraction. So the inverse of 4 over 4 is the same thing as 4 all over 4. When you divide this, you're going to be having your r as 1 ohm. Right, so this is the resultant resistors in series. Alright, so now the 1 ohm is now in series with the 3 ohms and then the 4 ohms respectively. So to find the resultant of resistors in series, our formula is R equals to R1 plus R2 plus R3. Okay, so our R1, this 1 ohm is now in series, so it's 1 plus we have 3 plus we have 4. Okay, so adding these 3 together, we are going to have our answer as 8 ohms. So it means the correct answer for this question is A, 8 ohms. Alright, so the next question, question 7. Which of the following best describe the energy changes which take place when a steam engine drives a generator which lights a lamp? Which of the following best describes the energy changes which take place when a steam engine drives a generator which lights a lamp? A. Heat to light to sound to kinetic. B. Heat to kinetic to electricity to heat and then light. C. Heat kinetic to light to heat to electricity. D. Electricity to kinetic to heat and then to light. So the correct answer for this question now is option B. Option B is the right answer for this. Remember, conservation of energy, the law states that energy can neither be destroyed nor be created, but it can be transformed or converted from one form to the other. So what happened here is energy conversion, right? Okay, so we have heat energy converted to kinetic energy, which produce electricity. Then the electricity also is converted into heat. That heat now give rise to the light. So there are lamps that uses these methods to produce light. Example is our incandescent light or incandescent lamp, alright, and also electric filament lamps. They make use of this progression. So that is it for this question. The next question, question 8. Cathode rays are dash. Cathode rays are dash. A. High energy electromagnetic waves. B. Protons. C. Neutrons. D. Streams of electrons. Okay, the correct answer for this question is D. Streams of electrons. When we talk about cathode rays, we are talking about negative rays. Alright, so negative rays comprises of electrons, streams of electrons, while the opposite is our anode rays, which talks about the positive rays comprises of protons. So the correct answer for this question is option D. Option D is the answer for this question. Alright, so let's go to the next question here. Question 9. A narrow beam of white light can be split up into different colors by a glass prism. The correct explanation is that a narrow beam of light can be split up into different colors by a glass prism. The correct explanation is that A. The white light is an electromagnetic wave. B. The prism has all the colors of the light, of the white light. C. different colors of white light travel with different speed in glass. D. White light has undergone total internal reflection in the prism. For this question, the correct answer is C. Different colors of white light travel with different speed in glass. General speed for light is given as what? 3 kilometers per second. But when we have different colors, we have different speed in glass. So the correct answer for this question is our option C. Alright, so let's go to the next question. Question 10. Question 10, we have a diagram here. So the figure above represents a block and a tackle pulley system on which an effort of W newtons supports a load of 120 newton. If the efficiency of the machine is 40%, then the value of W is dash. Alright, so let's have the data we're given here. We're asked to find the effort, and then we have our effort represented here. Okay, our effort is represented by W here. So E is equals to W. Alright, and then we are given load. We're given load to be 120 newton. We're given efficiency to be equals to 40%. What again are we given? Alright, so if this is the case, then we are going to be using the formula for efficiencies to solve this question. Efficiency is given as mechanical advantage all over velocity ratio multiplied by 100. Multiplied by 100. Okay, and then our mechanical advantage is given as load all over effort. So putting these two formulas together, we have our efficiency is going to be equals to load over effort over velocity ratio multiplied by 100%. Okay, so this is the formula we're going to be using. So let's impute our data into the formula. Our efficiency is giving us 40 equals to, our load is giving us 120 all over effort all over. To find the velocity ratio now, you have to check your diagram. Okay, how many blocks do we have in the diagram? We have 6 blocks, so that's mean the value for the velocity ratio is 6 multiplied by 100. Okay, when we cross multiply this, 40 is going to multiply 6. We're going to have 40 times 6 equals to 120 all over E times 100. Right. So when we simplify this, we're going to have 40 multiplied by 6. When we multiply 40 by 6, we're going to have our answer as 240. 240. So we have 240. This will also multiply the E here if we cross multiply again. So we're going to be having 240 E equal to 120 times. Okay, so we have it as 240 E equals to 120 times 100. Alright, so we're going to be having it as what? 240 E. Remember, our E is represented as W, so that's what we're looking for. 120 times 100 is going to give us 12,000. So to find E now, we're going to divide both sides by the reciprocal, which is 240. So 12,000 divided by 240. Our E now is going to be, we divide 12,000 by 240, we will have our answer as 50. Okay, so it's going to be equals to 50. Remember, we're looking for effort, so it means effort is giving us 50 newton. Our effort is the same thing as our W. W equals to E equals to 50 newton. So the correct answer for this question is option B. So let's move to the next question. What type of reaction is represented by the following scheme? What type of reaction is represented by the following scheme? So the scheme is displayed on the screen here. Option A, fission reaction. Option B, fission reaction. Option C, chain reaction. Option D, radioactive reaction. Okay, if you look closely, you're going to see this. When we talk about fission reaction, it's simply talking about that's combination of light nuclei to form a large nucleus, and then by that reaction there is a release of energy, while fission talks about the splitting of large nucleus into light nuclei. Okay, then chain reaction is the product of fission reaction. Then radioactive decay, that's talking about emission, right? So the correct answer for this question is option A. So correct answer, the fission is the correct answer here. So the next question, question 12. It says the amount of heat needed to raise the temperature of 10 kg of copper by 1 Kelvin is 8 dash. The amount of heat needed to raise the temperature of 10 kg of copper by 1 Kelvin is 8 dash. A, specific heat capacity. B, latent heat. C, heat capacity. And then D, we have as internal heat. So the correct option for this question is C, heat capacity. Heat capacity is the amount of heat needed to raise the temperature of 10 kg of copper by 1 Kelvin. Alright, then specific heat capacity now is seen as the precise or the definite. Okay, so like I was saying, the specific heat talks about the definite heat or the precise amount of heat needed to raise the temperature of 10 kg of copper by 1 Kelvin. Okay, the latent heat here talks about the conversion from one state to the other, solid to liquid, liquid to gas, etc. So the correct answer, as I said here, is option C. Option C is the correct answer here. So let's move to the next question. Question 13. Question 13 says the electrochemical equivalent of silver is 0.0012 grams per coulomb. If 36.0 grams of silver is to be deposited by electrolysis on a surface by passing a steady current for 5 minutes, the current must be... Okay, so this question is asking for current. Alright, so we can write down the given data here. Okay, we have the equivalent of the silver. Equivalent of the silver is represented by Z is equal to 0.0012 grams per coulomb. Then we have the mass is giving us 36.0 grams. Then we have the time giving us 5.0 minutes. Alright, so what are we looking for now? Current. We're looking for current now. Okay, so the formula we're going to use here, right? We have M equals to ZIT. Okay, so we're going to make I the subject of the formula in this question. So our I now is going to be M all over the coefficient of I, which is ZT. Alright, it's going to be equals to 36 all over our Z is 0.0012 multiplied by T, or T is 5 minutes. Alright, so 5 minutes, we have to take it to seconds. That's 5 times 60. Okay, 5 times 60. So when you multiply this and then divide 36 by the answer, you're going to have your answer as 100 amps. 100 amps. So it means option B is our right answer for this question. 100 amps. So that's the value of the current. So option B is the correct answer. Next question. Question 14. Shadows and eclipse result from the A. Refraction of light, B. Reflection of light, C. Diffraction of light, and C. Diffraction of light, and D. Rectilinear propagation of light. So the correct answer for this question is option D. Option D is the correct answer for this question. Option A, talking about refraction, it's simply when light hit a medium or a barrier, it changes direction. Reflection, when it hit a barrier, it bounces back. Diffraction is when light diffuses. Then the last one there, it's you can do a practical for this one using your pinhole camera, whereby you block set barriers and create a hole whereby your light pass through. So when there is a blockage, there will be no penetration of light. So we use this for describing shadows and eclipse. Okay, next question 15. Which of the following obeys Ohm's law? Which of the following obeys Ohm's law? A, all metals. B, diode only. C, all electrolytes. D, glass. The right option for this question is A, all metals. All metals obey Ohm's law. Remember, our Ohm's law states that what? The metallic conductor, the current, right, is directly proportional to the potential difference. The more the current, the more the potential difference, and by extension is inversely proportional to the resistance, provided every other factor is kept constant. So all metals obey Ohm's law. Next question 16. Which of the following statements are true of isotopes? Which of the following statements are true of isotopes? 1. Isotopes of an element have the same chemical properties because they have the same number of electrons. 2. Isotopes of element are normally separated using physical properties. 3. Isotopes of an element have the same number of protons in their nuclei. So which one is the correct answer for this? A, 1 and 2 only. B, 1 and 3 only. C, 2 and 3 only. And then D, 1, 2 and 3. So which one is the correct answer here? Our correct answer for this question is option C. Option C. Alright, so talking about isotopes, 2 and 3 is correct. Isotopes of element are normally separated using physical properties, and also isotopes of an element, they have the same number of protons and their nuclei. Right, so let's go to the next question. Next question here is question 17. 17 says, calculate the upthrust of an object of volume 50 cm3, which is immersed in a liquid of density 10 to the power 3 kilogram per meter. Alright, the density here is supposed to be 10 to the power minus 3 kilogram per meter. Alright, so let's solve this question. Our upthrust U, right, is giving us what? mg. Right, our upthrust U is giving us mg. We talk about upthrust, it simply means the upward force, an upward force that pulls something or push something down, or upward rather. Okay, so we have g here is a constant, that's acceleration due to gravity field, but mass, we've not been given mass. Okay, so for us to find mass now, we are been given density and we've been given volume. So we use the formula for density, which is D equals to m all over v. Alright, m now is going to be equals to, just multiply, you have it as dv. Okay, our m is going to be equals to our d, that's 10 to power minus 3, right, multiplied by volume, which is 50. Our m now is going to be equals to, when you multiply this, the same thing as dividing 50 by 1000, you're going to have it as 0.05 kilogram. Right, if that's our m, then our u now upthrust is going to be equals to, our mass is 0.05, right, multiplied by g, which is the acceleration due to gravity falls, constant 10 meter per second. Our upthrust now, multiply this, you're going to have 0.5 Newton. So the correct answer for this is option C, 0.5 Newton. The next question, Which of the following may be used to explain a mirage? Mirage. A. Layers of air near the rod surface have varying refractive indices in hot weather rather. 2. Rod surfaces sometimes become good reflectors in hot weather. 3. Light from the sky can be reflected upwards after coming close to the rod surface. Okay, so which of these explain a mirage? Option A, 1 and 3 only. Option B, 2 and 3 only. Option C, 2 only. Option D, 1, 2 and 3. Okay, so for question 18, the correct answer is A, 1 and 3. Talking about mirage, layers of air near the rod surface have varying refractive index in hot weather, and also the light from the sky can be reflected upwards after coming close. Right, after coming close to the rod surface. So the right answer is A. Next question, 19. The motion of smoke particles from a chimney is typical of. The motion of smoke particles from a chimney is typical of. Okay, smoke particles, diffuse particles. A. Oscillatory. B. Translational. C. Random. D. Rotational. So talking about smoke, it has no direction. Alright, no direction, no bearing. So the correct answer is random motion. Smoke is an example of a random motion, no direction. Next question, 20. Question 20 says, which of the following has the lowest internal resistance when new? Which of the following has the lowest internal resistance when it is new? A. Leclancher cell. B. Daniel cell. C. Torch battery. D. Accumulator. The correct answer for this question is accumulator. Accumulator has the lowest internal resistance when it's new. Question 21. The pitch of an acoustic device can be increased by. The pitch of an acoustic device can be increased by A. Decreasing the loudness. B. Increasing the amplitude. C. Increasing the frequency. D. Decreasing the intensity. The pitch of an acoustic device can be increased by simply increasing the frequency. So option C is the correct option for question 21. When you increase the frequency, then you are as well, increasing the pitch of the device. Next question, 22. One of the features of fusion process is that A. It leads to chain reaction. B. Its products are not radioactive. C. Neutrons are not released. D. The sum of the masses of the reactants equals the sum of the masses of the products. The correct answer for this is A. Remember when I was explaining a question we solved earlier, I told you that fission has to do with the splitting of large nucleus to form light nuclei. Alright, so it leads to chain reaction. So the correct answer for this is A. Next question, 23. It says the linear expansivity of brass is 2 times 10 to the power minus 5 per coulomb if the sum of the volume of a piece of brass is 15 centimeter cube at 0 degrees Celsius. What is the volume at 100 degrees Celsius? Alright, so let's get our data for this question. Okay, for this question now, we're given our linear expansivity as 2 times 5. Okay, sorry. Linear expansivity is giving us 2 times 10 to the power minus 5 per coulomb. Then the next thing we're also given is we have our V1, the initial volume now is giving us 15.00 cm cube, right? Then the temperature now, okay, the temperature now we have T1, or you can use theta, it's giving us 0 degrees. Then we have T2 giving us 100 degrees. Alright, so V2 now is the new volume we are asked to find. V2 is equals to question mark. Alright, so our formula is giving us what? Formula for linear expansivity is giving us alpha equals to the change in volume, which is V2 minus V1 divide by our initial volume and then change in temperature. Right, so in imputing the data into this formula, we're going to be having our alpha now, which is linear expansivity, is 2 times 10, right, power minus 5 equals to our V2 now, we don't know what our V2 is, minus our V1 is 15, right, divide by our V1 again, which is 15, into our V2 is 100 minus V1, T1 rather, which is 0. Okay, so when we cross multiply here, we're going to be having, our linear expansivity is going to multiply the denominator, right? We're going to be having 2, alright, 2 times 10 to the power minus 5 times 15 into 100 minus 0, okay? Then this is going to be equal to V2 minus 15, alright? So the coefficient of V2 now is minus 15. So if you want to make V2 the subject of the formula now, it's going to be V2 equals to minus 15 is going to cross the equal sign, it will turn into positive, right? So we're going to be having 2 times 10 to the power minus 5 multiplied by 100 minus 0 is 100. 100 times 15, that's 1005. So we have this as 1500, then plus our V1, which is 15. Okay. So when we multiply these all together, okay, if you multiply these all together, we're going to have our answer as 15.03. 15.03. Remember, is volume, CMQ. Alright, so our correct answer for this question is option D, 15.03. So let's go to the next question here. Right, the next question says, a lead bullet of mass 0.05 kilogram is fired with a velocity of 200 meters per second into a lead block of mass 0.95 kilogram. Given that the lead block can move freely, the kinetic energy after impact is, okay, so we have two masses here, but we have only one velocity here. And remember, the formula for our kinetic energy is giving us what? Ke is giving us half mv square. Alright, so now we have to find v now. Okay, we have to find v. We're given two masses, one velocity now. So to find v here, we're going to use the formula momentum m1 v1 equals to m2 v2. Alright, making v2 the subject formula here, we're going to be having m1 v1 all over m2. Right, our v2 now is going to be equals to our m1, and this is 0.05 multiplied by our v1 is 200 all over our m2 is 0.95. So if you multiply this, divide and then multiply. Okay, if you multiply and divide this, you're going to have 10 here. You're going to have 10. So our v2 is 10 meter per second. 10 meter per second. Right now, to find the kinetic energy from our Ke equals to half mv squared, we now have our Ke equals to 1 over 2 times our m now is a combination of 0.05, right, plus 0. Okay, let me use a better place now for us to see it clearly. Okay, so we have a good space to solve it now. Our Ke now is going to be equals to half our m. We have two masses here, that's 0.05 plus 0.95, right? Then your v now is the one we solve here, which is you multiply it by 10 squared, right? You multiply by your 10 squared, right? That's our v now. So when you multiply this all through, right, this is going to be the same thing as what? When you add this and this, 0.05 plus 0.95 is going to give you 1. So 1 times 1 is still 1, right? Then the square of 10 now is going to be give you 100. Alright, so when you divide 100 by 2, you're going to have your final answer as 50. Remember, energy is measured in joules, so this is our correct answer, 50 joules. So option C is the correct option in this question, right? Alright, so we have another question here. So let's solve this question. It says a car accelerates uniformly from rest at 3 meters per second. Its velocity after traveling a distance of 24 meters is dash. Okay, so let's get the data for this question. Right, the car accelerates uniformly from rest at 3 meters per second. From rest, that means our u now is equals to 0 meter per second, right? So the acceleration now, a, is equals to what? 3 meter per second square, right? Then what else do we have? We have distance, s, as 24 meter. Alright, so what's the formula we're going to use here? The formula that is going to be okay with this question is from our equation of motion. We have the third formula as v square equals to u square plus 2as. So this is the formula we're going to be using. Substituting, your u now is 0, right, plus 2 multiplied by acceleration, which is 3, multiplied by your distance, which is 24. Okay, so your v square now is going to be equals to, when you multiply all of these, we're going to have 144. So for us to find v, we have to take the square root of 144, right? So the v now is going to be equals to 12 meter per second. So the correct answer for this question is option D, 12 meter per second. Next question, question 26 rather. Okay, says if the fraction of the atoms of a radioactive material left after 220 years is 1/6, what is the half-life of the material? If the fraction of the atoms of a radioactive material left after 120 years is 1/6, what is the half of the material? Okay, talking about the half-life of a material now. Okay, our half-life of a material, right? Half-life of a material is giving us the total life. Total life divide by the stages, right? Total life divided by the stages is going to give us the half-life. So in this question now, the total life is giving us 120 years. So divide by the stages. The stages here is giving us what? It's giving us 1 all over 6. 1 all over 6. So this now, this that we've written now is the same thing as, so this that we've written now, okay, is going to be the same as, we have these as 120, right, divide by 1 all over 6. Okay, so this one now is the same thing as 120 all over 6. So it means the half-life is going to be equals to, we divide 120 by 6, you're going to have 20, right, 20 years. So that's mean option A is the correct answer for this question. The half-life of the life is 20 years. The half-life of the material is 20 years. So the next question here is question 27. Question 27 says, an object is projected with velocity of 80 meters per second at an angle of 30 degrees to the horizontal. So the maximum here, the maximum reach is dash. Okay. Alright, so for this question, let's get the data given in the question. Right, so we have our velocity now as 80 meter per second, right? Then we have our angle theta as 30 degrees, that's to the horizontal. So we are asked to find the maximum height, h. Alright, so these projectiles, maximum height is given as what? U square sine square theta all over 2g. So putting the data into our formula now, when we substitute this, we're going to have our maximum height as equals to 80 square sine square theta, which is 30 degrees, right, all over 2 times our g is acceleration due to gravity fold, which is constant, 10. Okay, so when you multiply all of this and then you divide, you're going to have your maximum height reach as 320 meter. So option D is the correct answer for this question. Option D is the correct answer here. Alright, so let's go to the next question, question 28. Question 28, it says that the time rate of loss of heat by a body is proportional to the time rate of loss of heat by a body is proportional to the A, temperature of the body, B, difference of the body, C, difference in temperature between the body and its surroundings, D, ratio of the temperature of the body to that of its surrounding. So for this question, the correct answer here is option C. Alright, the rate of loss of heat by a body is proportional to the difference in temperature between the body and its surrounding. Right? So whether the temperature is high or is low is going to determine how the heat is going to lose or gain or maintained by the body. The next question, 29. A positively charged rod X is brought near an uncharged metal sphere Y and is then touched by a finger with X in place. When the finger is removed, the result is that Y has A, no charge and a zero potential, B, a positive charge and a zero potential, C, a negative charge and a positive potential, D, a negative charge and a negative potential. The correct answer for this question is option D, a negative charge and a negative potential. Alright, the law of electricity, how that like poles repel, unlike poles attract. But when you have a pole, being it positive or negative, and you touch, a neutral body with it, is going to produce the opposite. So when you have positive charge rod, when you brought it near an uncharged body, you're going to have negative charge and a negative potential. So option D is our correct answer for number 29. Next question. Electrical appliance electrical appliances in homes are normally earthed so that electrical appliances in homes are normally earthed so that A. A person touching the appliances is safe from electric shock. B. Both the AC and DC sources can be used. C. The appliances are maintained at a higher potential difference than the earth. D. Appliances are maintained at lower potential difference than the earth. For this question, the correct answer is A. A person touching the appliances is safe from electric shock. So that's the number one, the primary reason for earthing electrical appliances. The word earthing there is talking about grounding. So the aim is to prevent electric shock. Option A is the correct answer. 31. The process whereby a liquid turns spontaneously into vapor is called A. Regulation. B. Evaporation. C. Boiling. And D. Sublimation. Alright, the correct answer for this question is evaporation. It's simply the process whereby a liquid turns spontaneously into vapor. Evaporation. Boiling. Sublimation talks about from solid directly into gas. Boiling, which is likely compared with melting, a body turning from solid to liquid, and then regulation there. So the correct answer for this question is option B. Next question, 32. The difference observed in solids, liquids, and gases may be accounted by. The difference observed in solids, liquids, and gases may be accounted for by A. Their relative masses. B. Their melting point. C. The spaces and forces acting between the molecules. D. The different molecules in each of them. The correct answer for this question is option C. The spaces and forces acting between the molecules is what differentiate gas from solid and from liquid. That's the space distance between the molecule bring the difference. So the correct answer for this question is option C. Next question, 33. Convex mirrors are used as driving mirrors because images formed are dash. Convex mirrors are used as driving mirrors because images formed are dash. A. Erect, virtual, and diminish. B. Erect, real, and diminish. C. Erect, virtual, and magnified. D. Inverted, virtual, and then diminish. The correct answer for this question is A. Convex mirrors are used as driving mirrors because the images formed on them are erect. That means upright, virtual. That means they're not clearly seen, though they are visible to the eye. And then diminish means they are not magnified. So A is the correct answer. Convex mirrors give images that are erect, virtual, and then diminish. The next question, 34. Musical instruments playing the same note can be distinguished from one another owing to the difference in their dash. Musical instruments playing the same note can be distinguished from one another owing to the difference in their dash. A. Quality. B. Pitch. C. Intensity. D. Loudness. The correct answer for this question is B. Alright, the difference in the pitch is going to help you to differentiate between instruments that are playing the same note. Next question is 35. In homes, electrical appliances and lamps are connected in parallel because A. Less current will be used. B. Less voltage will be used. C. Parallel connection does not heat up the wires. D. Series connection uses high voltage. Alright, so this is voltage. Sorry, it's not very clear here. Right, this is voltage. Alright, so we have this as voltage, and that is the correct answer. The reason why electrical appliances and lamps are not connected in series is because series connection uses high voltage. Instead, they are connected in parallel. Electrical appliances, they have their connection, such as the fans, the socket for your AC, TV, and other things separate, and then the one for your lamps to separate. because series connection uses high voltage and can get your appliances burned. So the correct option for this is series connection uses high voltage. Next question, 36. An object moves in a circular path of radius 0.5 meter with a speed of 1 meter per second. What is its angular velocity? An object moves in a circular path of radius 0.5 meter with a speed of 1 meter per second. What is its angular velocity? Alright, so this question we're given our radius here is given us 0.5 meter, right? And then we have our speed now. Our speed is giving us 1 meter per second. So our speed, let's represent speed with V now. It's giving us 1 meter per second. So what are we asked to find here? We're asked to find the angular velocity. W is equals to question mark. Right, so the formula we're going to be using now is the formula for velocity, which says V is equals to WR. Right, since we're looking for W now, our W is going to be V all over R. Our V is giving us 1, R is giving us 0.5. V is giving us 1, R is giving us 0.5. When you divide 1 by 0.5, you're going to have your answer as 2. So the unit of angular velocity is rads per second. That's 2 rads per second. Right? 2 rads per second. So that's mean option D is the correct answer for this question. Okay. Right, so the next question is question 37. Which of the following is a fundamental unit? Which of the following is a fundamental unit? A. Newton, B. Watt, C. Joule, and D. Second. So which of these is a fundamental unit? Alright, option D is a correct answer for this question. Second. So we have two types of units. We have the fundamental units, we have the drive units. The fundamental units are also called independent units. Alright, they're the units that form other units. The drive is the opposite. Drives are gotten from fundamental units. So second here, time is a fundamental unit. We have other ones such as length, such as mass, etc. The remaining ones here are drive unit. We have Newton is for force, Watt is for power, joules is for energy or work. Right, so the correct answer is D. Question 38. A machine gun with a mass of 5 kg fires a 50-gram bullet at a speed of 100 meters per second. The recoil speed of the machine gun is dash. A machine gun with a mass of 5 kilograms fires a 50-gram bullet at a speed of 100 meters per second. The recoil speed of the gun is dash. Okay, so let's get the data given in the question here. Right, the first thing here we have a mass of 5 kg now. So a mass of 5 kg here fires a 5 kg bullet at a speed of 100 meters per second. We're going to be using this formula. We'll write our m1 v1 equals to m2 v2. Right, that's mass and velocity. This is simply talking about momentum, right? Change in momentum. Okay, so now what are we looking for now? The question is talking about the speed, the recoil speed of the machine. That's our v2 now. Okay, making v2 the subject formula here. Our v2 now is going to be m1 v1 all over m2. Okay, so our m1 in this question is our 50. Right, let me write the data here. m1 is 50 grams, but you know mass is measured in kilograms, so when you convert this to kilogram, you have divide this by 1000, you have 0.05 kilogram, right? 0.05 kilograms. Then your m2 is your 5 kilogram, and then lastly your V1, that's initial speed, 100 meter per second. Right, so when we put these values here, we're going to be having 0.05 multiplied by 100 all over 5, right? So now our V2, 0.05 times 100 is going to give you 5. 5 divided by 5 is going to give you 1 meter per second. So that's the recoil speed of the machine gun. So that's mean the correct answer for this question is 1 meter per second. Right, the next question here, question 39. Okay, so we're going to start by bringing out the data in this question. Alright, so that you don't occupy much space, let's just solve it directly. Alright, the first statement here is the cost of running 5 50 watt lamps. So that's mean we're going to start by 5 times 50 watt lamps. When you multiply 5 times 50, you're going to get 250, right? So you're going to get 250. So the next one is, and for 100 watt lamps, that's 4 times 100 watts. It's going to give us 400 watts right now. So the total of the power now is going to be 250 watts plus 400 watts will give us 650 watts. Right, so now it's talking about okay, the cost of running this power for 10 hours. So we're going to multiply the power by the hours. Alright, so the hours is 10 hours. So we have 650 watts multiplied by 10 hours. Okay, but before that, our power is measured in kilowatts, not watts. So for us to take this one to kilowatts, we have to divide 650 by 1000, which is going to give us 0.650 kilowatts, right? So it means this one is 0.650 kilowatts, right? Multiplied by 10 hours, so that we have our answer in kilowatts per hour. When you multiply these two, we're going to have 6.5 kilowatt per hour, right? We're going to have kilowatts per hour, 6.5 kilowatts per hour right now. And then the energy cost of these lamps is 2 kobo per kilowatt. So we're still going to multiply 2 kobo per kilowatt. Right, let's create space here. Right, so we have 6.5 kilometer, alright, per hour. Okay, the energy cost is 2 kobo per kilowatts per hour. Kilowatts per hour. Sorry, I said kilometer per hour here. This is kilowatts. Okay, kilowatts per hour. So when you multiply the power now, which is 6.5 kilowatts per hour, right? Kilowatts per hour, you multiply it by the amount, which is 2 kobo. We're going to be having 6.5 kilowatts per hour multiplied by 2. Alright, so when we multiply this by 2, alright, so when we multiply the power by the amount here, which is 2 kobo, we're going to have our answer as 13 kobo. Right, so when we have 13 kobo, 13 kobo here, but we will write our answer in naira. So to take this to naira, we have to divide it by 100. So 13 kobo is the same thing as 0.13 naira.
Let me tell you, there is some fight that.
So the correct answer for this question is option D, 0.13 naira. So let's go to the next question, question 40. Okay, so we have the question 40 here. A transformer has 300 tons of wire in the primary coil and 30 tons in the secondary coil. If the input voltage is 100 volts, the output voltage is dash. Okay, so let's get the data given in this question. Right, so we have the primary ton, let's label it NP, is giving us 300. Then we have the secondary ton, NS, is giving us 30. Then we have the input voltage, which is the input current voltage rather, which is the NEP. That's the voltage at the primary coil, is giving us 100 volts. Right, using our formula is giving us ES all over EP equals to NS all over NP. So what we are looking for now is our secondary voltage, which is ES. So making ES the subject formula in this equation, we're going to be having
This pause, right?
yeah. So our ES now is going to be equals to, we have our ES is equals to EP multiplied by NS all over the NP. So substituting the values into our formula now, our EP here. Okay. So when we substitute into the formula, our ES now is going to be 100 times 30 all over 300. So now the secondary voltage, which is ES, 100 multiplied by 30 will give us 3000. When you divide it by 300, you're going to have 10. So 10 volt is the voltage at the secondary coil. So that means our answer for this question is option B. Alright, thank you so much for staying with me. I hope you enjoyed this lesson. I hope you've gained a lot. I remain your Jeff Tapita from IDC Learning Center.